Good morning, dear students. As we are in the last unit, even in that unit also, we have discussed several topics about distribution system. See, when we have a look in the past 5 units, we understood and we discuss various topics related to water supply. Yes, this E1 of your curriculum. Today we are going to discuss about the topic as in a continuous part to the previous session. That is pressure in the distribution system we are discussing. Why the pressure has to be maintained? What are all the factors we must consider, especially to maintain the pressure in the pipes carrying water to the buildings. The building height has to be considered. The first 2 points we discussed more elaborately in the previous session itself. Here, the pressure which is required to be maintained in the distribution system depends on the following factors. What are those following factors? Number one, the building height of the building, up to which height the water has to be sent. Next one is distance from the locality to the distribution reservoir. What is the distance of the locality to that distribution reservoir? Second point. Third point, the supply is to be metered or not. Whether supply is metered or not, the budget that is available for the project. See, these are the factors which we must consider. Building height, distance from the local to the local distance of the locality to the distribution reservoir, either supply is metered or not, and sufficient funds has to be there or not for better quality pipelining. See, generally, for multi-story buildings, the following pressure conditions are considered as satisfactory. See, in the previous case, we have seen the pressure which is required to be maintained in the distribution system depends on the following factors. Pressure, the required pressure to be maintained in the distribution system depends on height of the building, distance of the locality from the reservoir, distribution reservoir, either supply is metering or not, and good sufficient funds are allocated or not. See, generally, for multi-story buildings, the following pressure conditions are considered as satisfactory. See, what are those following considerations? See here, nothing is there here. Up to 3 stories, the pressure in the distribution system is 2.1 kg per centimeter square. If it is 3 to 6 stories, 2.1 to 4.2. And if the height, if the building is 6 to 10 stories, that is 4.2 to 5.27 kg per centimeter. And above 10, normally the required pressure to be maintained is 5.27 to 7 kg per centimeter square. See, while designing pipes for distribution system, our next point is the following point should be followed. That means the following point should be considered. The time of, while designing pipes for distribution system, the main line should be designed to carry 3 times to the average demand. The main line we have seen. The main line, what is the main line? This is the main line. This is the main line. How much? The main pipeline must be selected in such a way it can carry 3 times to the average of carrying water. See here, should be designed to carry 3 times to the average demand of the city. The service pipes, next we have seen the service pipes also in there itself layout. The service pipe should be able to carry twice to the average demand. And the dog, see here, these 2 points has to be kept in the mind. And the water demand of various locations should be noted. Along with these 2 points, one more thing is the water demand of various locations should be noted. Next is there should be clear marking on length and size of each pipe in the site plan, along with the meters, valves, hydrants, etc. In the pipelines, the minimum velocity should not be less than 0.6 meters per second, and maximum velocity should not be more than 3 meters per second. See, velocity at different pipes with respect to its diameter is as follows. The pipe diameter is 10 centimeter, the velocity is 0.9 meters per square. The diameter of pipe is 15 centimeters, 1.1 meters per second. 25 centimeters, 1.52, 40 centimeters, 1.8 meters per second. See here, we have seen various consideration with respect to velocity, with respect to pipelines, with respect to pressure, with respect to head glass. Sufficient height has to be maintained by considering the height. So whenever you got the question, write a detailed notes on pressure in the distribution system. You must remember sufficient pressure has to be maintained in the pipelines, and it is not up to mark but it is losing due to the friction in pipes, entrance of reducers, valves, vents, meters, etc. There should be sufficient. Next point is there should be sufficient head in the pipes connected to the building by considering their height. Normally, the pressure in the distribution system, or as the required pressure in the distribution system, if the pipes are laid to the building, they must consider building height, distance from the, distance of the locality from the service reservoir, and the other one is whether the supply is metered or not, and sufficient budget. Apart from that, we also should consider the pressure, exact pressure. What is the exact pressure has to be maintained. For up to 3 stories, the required pressure 2.1 kg per centimeter square pressure has to be maintained in the pipelines. Then only the water will be supplied without any issues, without any supply related issues. And if the building height is 3 to 6 stories, the required pressure is 2.1 to 4.22 kg per centimeter square. And thirdly, if it is 6 to 10 stories, the pressure is 4.2 to 5.27 kg per centimeter square. And the last one, if the height is above, 10 stories, the required pressure is 5.27 to 7 kgs per centimeter square. While designing pipes for distribution system, the following points should be considered. What are those points? The main pipeline should be designed to carry 3 times to the average demand of the city, and the sub pipelines or service pipes should be able to carry at least 2 times of carry twice to the average demand, and the water demand of various locations should be noted. See, while while designing pipes for distribution system, these points has to be kept in the mind. See here, and apart from those 3 points, there should be clear marking on the length and size of each pipe in the site plan, along with the meters, valves, hydrants, etc. What we are discussing, pressure in the distribution system. See here, in the pipelines, the minimum velocity should not be less than 0.6 meters per second, and maximum velocity should not be more than 3 meters per second. Normally, velocity at different pipes with respect to its diameter is as follows. When the pipe diameter is 10 centimeters, the required velocity is 0.9 meters per second. Likewise, for 15 centimeters, for 25 centimeters, for 40 centimeters, against velocity is here 1.1 meter per second, 1.52 meters per second, 1.82 meters per second respectively. See here, that means for 15 centimeters 1.1, 25 centimeters 1.52, 40 centimeters 1.8 meter per second. These are the, I mean, values, or these are the, figures with respect to the velocity. What is the optimum velocity, and what is the, I mean, velocity has to, what is the velocity that is needed to be maintained in the pipes with respect to the diameter of the pipes. This is what about pressure in the distribution system. We discussed about the factors to be considered, and we discussed about the pressure at pressure conditions at different storage. We discussed overall points what we should consider while designing pipes. What is the type, what is the type of pipe we should select. For main pipes, it has to carry at least 3 times to the average demand. The service pipe should be carried twice to the average demand, and the water demand of various locations should be noted along with those two above specifications. And one more thing, one more specification also has given with respect to velocity and diameter. This is about the pressure in the distribution system. Okay, next we'll move to the next topic, that is testing of pipelines. Testing of pipelines. See, in the previous case, in the previous chapter, that means in the second chapter, we have seen types of pipes: asbestos pipes, concrete pipes, and steel pipes. We have seen Hume pipes. We have seen different types of pipes in the second region. Now here, testing of pipelines, how we can test these pipelines. First one is NDT, non-destructive testing methods must be carried out for the pipelines that are used for public water supply. And second one is welding. Welding areas on the pipeline should be checked out to find out their efficiency when they are intended to use for long period of time. The welding areas has to be checked out whether they have any problems or it is working properly or not, especially when the pipeline is expecting to work for long period of time. And third one is mechanical and environmental testing. Here, the third one is mechanical and environmental testing. What it is exactly doing here, mechanical properties of pipes such as ductility, strength, the behavior of the metal when they exposed to external environmental conditions should be checked with proper testing methods. The mechanical properties like ductility, strength, behavior of the metal when they are exposed to the external environment conditions, and they should be checked out with proper testing methods. And next one is hydrostatic test. The pipes are filled up with water or oil at specified pressure to find out their performance. These four are the testing of pipelines. Here, non-destructive testing, how we can test these pipelines. Non-destructive testing methods has to be adopted to find out its capacity and to find out its nature. Apart from the NDT test, the second one is welding. Welding areas has to be checked out, especially when these pipelines are intended to use for long period of time. And mechanical and environmental testing, the characteristics like ductility, strength, behavior of the metal has to be checked out, especially when they are exposed to external environmental conditions. All these parameters has to be checked out. That means ductility, strength, behavior of the metal when they exposed to the external environmental conditions should be checked with proper testing method. Next one is hydrostatic test. All the pipes which are going to be used in water supply system has to be filled up with water or oil at a specified pressure to find out their performance. The performance of the pipes has to be find out with by filling the pipes with oil and water, so that we can find out their capacity in the sense their performance. These four, NDT tests, welding tests, mechanical environmental testing, hydrostatic tests, are four basic tests and four important tests to test the pipelines. See here, in the previous case, pressure in the distribution system we discussed, and testing of pipelines we discussed. Hope you understood. And here, next topic already, see here, this almost we covered, not almost, we covered all the topics in the 6th unit. See here, if you have any doubts from the starting to ending, from the 1st unit to 6th unit, you are most welcome. You just make a call to me and or else message or pipeline, or mail, so that the doubts will be clarified. See here, have a look here. Let us see what we discussed in 6th unit. distribution of water, methods of water supply system. We have seen two types of water supply. One is continuous water supply. The other one is intermediate water supply, that is intermediate system. See here, after that, we have seen layouts of distribution system. Different types of layouts we have seen. The first one is dead end system, grid system, circular distribution system, radial system. These four are the layouts we have seen. See, they're followed by walls. See here, walls, sluice walls, and that you must learn how to draw, and you must learn these diagrams for this E examination, E1 curriculum. Without diagrams, your all your efforts goes to vain. By heart, or else try to learn all these diagrams one or more times so that you'll get good score in your examinations. See a check wall, air relief walls, score walls. All we discussed. We have discussed the pipeline methods, pipe method, Hardy cross and equivalent pipe method. Next one is pressure in the distribution system. Here, after this pressure in the distribution system, we have seen the testing of pipelines. See here itself, when you have a look, types of pipes we have discussed in the second unit itself. Types of pipes and laying of pipes. Again, it is in the, see here, discussing point here, types of pipes we discussed, and laying of pipes we have seen. Laying of pipes. See, in the second unit, we were already discussed. See here, after joints, the types of pipes. And pipe materials, cast iron pipes, wrought iron and steel pipes, concrete, all these pipes, how to check? NDTs, welding methods, mechanical properties like ductility, strength, all behavior when they exposed to the environment has to be checked out. Along with that, hydrostatic test has to be conducted to find out their performance. We have seen now concrete pipes, fume steel pipes, asbestos cement pipes, wood pipes, service pipes, plastic pipes. We were discussing. Consideration for laying pipelines also we were discussed more elaborately. Proper planning, alignment of roads, excavating trenches, bottoming of trenches, placing of pipelines also we discuss how to place pipelines, backfilling and backfilling or refilling. After that, here joints we discuss. See the walls and joints both are parts to the pipes. See here, to be fixed for better water supply. See here, what are all the different precautions we must consider? Pipe joints, imperviousness, adhesiveness, durability, elasticity, availability, strength, and all these we are discussed more elaborately in the previous class itself. See here, types of joints: pivot joint, screwed joint, collar joint, flanged joint, expansion joint. Likewise, we was discussed many types of joints as per your curriculum. And mass curve method we discussed to find out the storage capacity. Here, see, we discussed mass curve method where, see, required storage capacity. We found out, we found required storage capacity by using this mass curve method. See here, and after that, we entered into the third unit where we learn all the IS quality standards, IS 10500-2012 standards, and comparison of water and its quality and quantity. We learn physical characteristics of water, color, taste and odor, turbidity, solids, chemical characteristics, pH, conductivity, salinity, alkalinity, hardness, heavy metals, dissolved oxygen, chemical oxygen demand, BOD, and biological characteristics we discussed, fecal matters, E. coli, and WHO guidelines we were discussed. And with this WHO guidelines, and the physical chemical analysis of water. We finished third in it and entered into the treatment of water. This physical, chemical, and biological analysis of water, somehow we learned in the manual. See a treatment of water. See a treatment of water layout or flow chart of treatment of water. See, we entered into the fourth in it. See, all these are the WHO guidelines you must learn. Here only ISO standards, characteristics of water, WHO standards, and the next one is analysis of water. Physical, chemical, biological analysis of water. Somehow you learn and through the materials. And next one we enter into the treatment of water, where we learn sedimentation, principle of sedimentation, different zones, design aspects, detention periods, problems, and types of sedimentation tank, rectangular tanks, circular tanks, upper bottom tanks. All we learn. And finding of optimum coagulant dose, flocculation, flocculator, coagulant examples, filtration. What is happening exactly in filtration? We have seen mechanical stirring, sedimentation, bacteriological action, electrolytic action. And there are two types of filtering: slow sand filters, rapid sand filters, backwashing of filters in the associated part of rapid sand filters. After that, we entered into the fifth in its theories of disinfection. Boiling of water, ozone, ultraviolet, iodine and bromine, potassium permanganate, excess lime, we discussed more elaborately. And the chlorination, also one of the disinfectant method. Here we discuss more elaborately about this chlorination, superchlorination, double chlorination, plain chlorination, dechlorination, pre-chlorination, post-chlorination, chlorine demand, breakpoint of chlorination, advantage of breakpoint of chlorination. Reserve and next topic, reverse osmosis. And what is osmosis? We learned adsorption, ultrafiltration, removal of iron and manganese by different method, oxidation with aeration, oxidation with chlorine. We discuss how we can remove iron and manganese. After that, removal of color and odor, we discuss. Fluoridation, we have discussed what is fluoridation and what is defluoridation, Nalgonda technique. And distribution of water in this unit, we are here. Methods of water supply, continuous water supply, intermediate water supply. Just now we already discussed about all these things. Layouts of distribution system, followed by walls, different types of walls, pipe systems, Hardy Cross and equivalent pipe methods, present in the distribution system, testing of pipelines. Thank you. If you have any doubt, you please contact me. If you have any doubt, right from first unit to sixth unit, you please contact me, either phone, message, or mail. The material will be available in the store as in hard copies. Thank you.